Hello all, welcome back to the channel and welcome to the course on integral calculus. Properly we are going to study about the integration by parts. So sometimes it happens that whenever we come across the integration process, suppose if I write sec cube x dx integration, and if we came to know that this integration is not possible without applying any substitution, if we got to find out any substitution, then it is not possible to integrate the following expressions, right? So at that time we came to know a concept of integration by parts. So basically what will I do, I will bifurcate this sec cube x as sec x into sec square x dx. Now I will got two functions, first and second. So appropriately we decide according to our feasibility that what will be the first function and what will be the second function, and accordingly we will do the integration, right? So now let us first understand the rule. This is called the UV rule. Like if we recall, in the case of differentiation, if we see came across the case of differentiation, then at that location, at that concept, we have seen the concept of UV rule or the product rule, right? So similarly in case of integration also there is a UV rule, and that rule is known as basically the integration by parts. So this rule states what? If I consider u as the first function and v as the second function, then the rule states that first function remains same, ठीक है? Then integration of second function with respect to dx minus whole integration differentiation of first function into times integration of second function, and this ka and this is the raised to whole integration dx, right? So this came to be known as the integration by parts rule, right? So what we have done, let us recall again. We have considered the first function and second function, then first function remains the same and integration of second function, subtracting from the whole integral of d by dx of first function integration of second function or raised to whole dx का integration, right? So in this way we have understood the concept of integration by parts. Now there are some points which must be kept in mind before proceeding further, that if we take the UV rule, then these conditions need to be followed or checked accordingly, right? So there is a note. So note, what is the note? The note states that first, while integration by parts, so what we are discussing, we are saying that while performing integration by parts, whenever we are doing the integration by parts, then there should be kept in mind that this integration v dx should be simple. So it should be taken, v should be taken as such among the two functions. The v function should be taken among the two function as such a function, then whenever whose integration we want going to do, then it becomes very much simple, right? So now also if we have to integrate this term, right? So d by dx of u into integration of v dx raised to whole dx, right? So this integration needs to be also very much simple, right? So that should be kept in mind. Other than that, so keeping the order of the uv as per the order of the letters. So right, most important thing, now we have seen the uv rule, right? This is also known as, now this is the turning point around the concept, that it is also known as the what rule? It is also known as the Eilert rule. So Eilert is what? Stands for inverse trigonometric, L for logarithmic, A for arithmetic, T for trigonometric, E for exponential. So right. So all these letters. So according to the preceding in letters Eilert, we have to choose the order of the U, right? So first function should be according in the series with the so Eilert. So first of all, if there is an exponential function, then this should be always take as a first function in the reverse order, right? Right? So order should be kept in mind. Other than that, let me take if ex fx plus f dash x, if this dx is present, then this integration is directly written as e power x fx. Why? Because there is a substitution method coming in working before applying the eyelet rule, right? So if this is the f dash x and this is fx, then this should be ex fx. If we want to see the difference, then we can also multiply each term separately with the fx and f dash x of e raised to x, then simply integrate. Then we came to know that the one term cancel out with the other term, and the remaining term would be becoming e raised to x fx, right? Okay, now also there is this integration x f dash x plus fx, right? Again, this is the kind of similar integration. Now this integration become x times fx plus c. Again this is also plus c. Also, if we came across such a function that fx into x raised to n, right? If such a function we came across such a function, then it should be kept in mind. Then we will be take xn as the first function always. So why? Because the first function remains the same in the first part, so it is easy to becoming xn. If we differentiate the xn, then it becomes difficult to integrate the fx function with respect to with along with the xn function, right? Okay, so now also if we take the integration as log x to the power n dx, then also what we'll be doing, taking the first as second function. So is this is completely the first function, right? So it is a missing here. You can see, if you clearly observe or minutely observe the situation, then we will came to know that here it is only one function comprises of log x and raised to power n. So it is a composite function of log x and x raised to n, right? So again, if we want to integrate it with with respect to dx, then we have to take 1, basically the numerical value 1 as the second function. So whenever we integrate the second function, integration will become x, and this should be become 1 by x, so that log x could be directly cancelled with the 1 by x term of the one integration function, right? So in the upcoming series we will be doing the integration, then you will came to know more about it, how do we proceed and how do we do the eyelet rule, right? So uh, it sometimes happens, students, that when we are going to integrate the second function or the first function with using eyelet rule, right, then it might become that after integrating one time, it again requires to integrate the function again with the second time. So don't hesitate at that time. Also please remember that always integrate the second function with respect to first function, right? Okay, sorry, pardon. What I'm saying that always we can apply the integration by parts repeatedly in the series to avoid uh, any misconception or to proceed with the integration, so that we will arrive at a complete result, right? Also, sometimes happens that if like जैसे like for example, if I take this example which I discussed in the starting of the lecture, so if I take this example, then you can see that there are two trigonometric functions all over, right? So what function should be taken as the first function and what to be second function? Then please remember that whose integration is simple. So here in this case, the sec square x integration is simple, so it should be treated as second and this should be first. So when we try to integrate, it becomes directly integrable, and then we can solve the required integration, right? And if both the functions are algebraic, right? So if suppose both the functions are algebraic, then what? Then take the function as first whose derivative is simple. So in the case of trigonometric functions, we take the second function as whose integration is simple. In case of algebraic function, we are taking the first function as that function whose derivatives are simple, whose derivative is simpler, right? So in this way we have um, done the concept of integration by parts. And if suppose if I say that if the function contains two inverse trigonometric functions, right, right, and an algebraic function. So if I take one inverse trigonometry and one algebraic, so let us suppose if I take x into tan inverse x, right, then what? Then in x use suitable trigonometric substitution, right? So what we are going to do, use suitable trigonometry, like we have to like what we have to eliminate this tan inverse, right? So we have to choose a suitable trigonometric substitution to avoid the tan inverse function and to become it simple, and then try to integrate, right? So in this way, this is the concept of Eilert rule, which is also known as the product rule of integration, right? Now in this upcoming part, we are going to study more examples so that our concept becomes stronger and we are able to solve much more questions in the same pattern. So let us start, right? So the first question is, as I have discussed, this is sec cube x dx, right? So what we're going to do, we will be separating the function in two parts, and again I have take this as the second function and this as the first function. So first function remains same, second function's integration tan x minus integration of differentiation of first function into integration of second function, right? So this is sec x, don't forget to put the equal to sign, it is very much important. Then minus differentiation of sec x would be integration as it is sec x tan x, and integration of sec square x is as tan x, right? Okay, right? Now what we will be going to do, sec x into tan x minus, now see sec x common, inside we have left out with tan x, right? Okay, so just a moment, this is into, right? So sec x, so again we have left out with sec square x tan x, right? So then tan x would be written as sec square x minus 1, right? So here, so here there are two tan x. Basically try to understand the concept which I have used here. This sec x is remain the sec x, right? Then this tan x would be written as tan square x, and we know that 1 plus tan square x is as sec square x. So this step is come from here, right? Now what will we do? Sec x into tan x minus sec x and sec square x minus 1, right? So again this is become sec cube x minus sec square x, right? Dx, right? Okay, so now clearly observe that if I started with the integration sec cube x, which is referred to as I, right? So this is I, so sec cube x is I, here also it is running I, and if I take I and then if I put sec x into tan x minus I minus sec square x, so this is become I and sec x tan x minus I minus tan x. Oh, sorry, this is only sec x, not sec square x. So this would be becoming sec x means integration, sec x means log of sec x plus tan x, right? Right? So this I will come this side, this becomes 2I equal to sec x tan x minus log of sec x plus tan x, right? So this becomes I equal to 1 by 2 times sec x tan x minus log of sec x plus tan x, right? So this we have solved. So it sometimes happens, students, that if we came across such an integration, and if the integration repeats itself in the coming in the solving while solving the integration, then we have to keep in mind that we have always have to put the value of the integration as I there, because we have let the integration as I, and then we have to eliminate I by using equation method, or if we say about the transforming method, right? Okay, so in this way we have solved this question. For your homework, I will give another question. Try to evaluate using by parts, and just make sure to identify the first function and second function properly, right? So this is the question. This is for your homework, students. So keep learning, keep enjoying mathematics, and subscribe to my channel Math and IT Pathshala for more such wonderful videos. Thank you so much and have a nice day.